Hello and welcome back to day 27 in 30 days of AWS Terraform. We have seen a lot of Terraform real-time projects. We have created multiple multi-tier architecture. We have deployed multiple applications. We have seen blue-green deployment. We have seen two-tier, three-tier projects. We have seen portfolio website or like S3 website static hosting and many other projects. But till now, we haven't covered one special aspect, which is how do we automate everything in Terraform using a CI/CD pipeline. So this is what we are going to do in this video. As you can see, we'll be using GitHub Action to automate the provisioning and management of infrastructure using Terraform with the help of GitHub Actions pipeline. So again, this will be the infra that will be provisioned. Okay, so let me just walk you through it first, what it is actually. So our developer over here and developer will issue a pull request to the GitHub repo to include their code changes to a feature branch. An approver reviews the pull request and approves it. Then it will trigger the GitHub action workflow. Okay, so we have created a GitHub actions pipeline. There is one pipeline for destroy the resources and one for provisioning and management of resources. So that pipeline will be triggered and it will have multiple branches like dev, test, main. So let's say for a feature branch, it will be triggered and then it will initiate TF-lint, which is a Terraform linting tool, and then 𝗔𝗲 for security scanning. Once that is done, it will plan and apply the changes using Terraform. It will use S3 backend for the state file management and locking, and then it will provision the infra or update the infra, and this is the infra. So basically it's a two-tier architecture with which is highly available, fault tolerant, because we are using auto scaling group that manages your instances in two private subnets, which has nginx installed to serve the application. And for the outbound access, as you can see, we are using NAT gateways, which through which these instances will download the updates from internet or to pull any packages from internet. And then on the public subnet, we also have an application load balancer. Okay, so that application load balancer is actually redirecting the traffic to the backend servers on the private subnet. And in the public subnet, we just have NAT gateways for each of the availability zones. So the user will come via internet through an HTTP or HTTPS request, and it will go to application load balancer. It will be redirected to the backend instances. These backend instances are managed by auto scaling group with minimum desired and maximum number of instances, and the application will be served. And this all will be happen with the help of a GitHub Action CI/CD pipeline. Okay, so that's just the gist of it. That's just how what we are doing and how we are doing, but we'll be doing multiple demos in this video. So I want to focus more on demo rather than the actual code, because code is I will focus on the GitHub action code, but other than that, the code is something that we have seen hundreds of times already in this series. And if you are following, like if you are just got to know about this series, I would highly recommend starting from the beginning of the series. Otherwise you will miss a lot of important topics that we have covered already, right? So, and if you are a regular follower, make sure you implement this project, make sure you do the hands on and understand each and every part of it. Try to improve it further, try to include more steps into it to make it one real time project. Okay, so let's go over here. This is our demo repository and this is what we're going to do. Okay, so you start with provisioning your S3 backend, which is a one-time thing. So I'll just copy this and I'll go ahead on my Visual Code and maybe run the command over here, or is there a script over here as well? So make sure you download the latest, check out the latest code. Okay, yeah, there is no backend.tf, so let me just create a file over here. And yeah, inside code, let's call it inside code, I'm gonna create a new file called backend.sh. Okay, paste the code over here, and this should, like, basically AWS CLI commands to create the S3 bucket. Okay, so this is the bucket name, and then enable versioning, enable encryption, and so on. Like, there should be like a step to make it a private bucket, but maybe I missed it, but that's fine. You understand what you want to do. Okay, and now let's give this a permission 775 backend.sh and execute it. So this should be our first step. Okay, it will create the S3 bucket. Now let's go back. In fact, let me just open this in a separate window so that it won't be confusing, and I will walk you through the steps over here. Okay, it says make bucket. This bucket has been created. Cool. Now update the backend with your Terraform bucket name. So I'll just copy this and go to backend.tf. Okay, and here's the bucket name. I think this is the same, but let me just update it. Okay, and with the bucket, because like S3 has now the support for native state file locking, we don't need to use the DynamoDB, so you just need to use log file equal to true within your backend, and that would be it. Okay, now we need to make some changes to the GitHub repository. So let's go back. Let's open the GitHub repo and let's go to AWS Terraform. This is day 27. Actually, not over there. So just go to settings of your repo, because we need to set the credentials for GitHub action pipeline, right? So over here, go to secrets and variables and actions. Now we need to set some variables, okay, for secret access key and secret access key ID. So manage environment secrets. Oh, over here, new repository secret. Okay, so secret name, give it AWS access key ID, and let me just do a quick login and go to IAM. Now over here, let's go to users, go to my DevOps user and go to security credentials. Let's create access key. Okay, CLI. Hit next and let's give it the name day 27 key. Create access key. So now just copy this access key from here, paste it over here, add secret. And another one, which is your secret access key, and you need secret access key over here, add secret. Okay, now go to environments over here. Okay, there are no environments for this repo. Click on new environment and enter prod as the environment name. Configure, and let's say required reviewers. Yes, we need a reviewer to review the pipeline before it actually executes it. And you can add yourself or your team member. For this demo, I'm going to add myself, but like you need to add your reviewer, the actual reviewer of your project. Okay, and then save protection rules. Okay, and then you can also create your dev and test environment for tracking purpose. So you can do that. Let's go back to environments and let me create dev, configure, and we don't need reviewer for dev. That's okay. And let's go back and create one more for test, configure, and save protection rules. Okay, now because this is a multi-environment setup, so what we are doing, we have multiple TF vars for each of the environments. Okay, so there is a dev.tf vars This is specifically for dev. Here we are saying if the environment is dev, t2.micro instance should be used, and this is the VPC that should be used. If the environment is prod, then you need to use these public and private subnet. This is the VPC that you should be using. These are all the other details that you should be using. And similarly, we have tfvar for test environment as well. Okay, so now we have already seen the workflow of GitHub Actions pipeline. Now what we need to do, we should start with creating a feature branch to check out the code. Okay, so let's do that. In our code repo, let's go back over here. Let's run git checkout -b. Let's create a new feature branch -fetch. Let's call it scale up dev. We're gonna make some auto scaling changes. Okay, now switch to a new branch, fetch scale up test, and let's go to dev.tfvars. And over here, let's change desired capacity from 1 to 2. Okay, and that's it. Save the file and let's just commit the changes. So git add inside code there were dev.tfvars. Okay, and then let's do a git commit -m. So we have added a new feature. Let's say scale up dev environment. Okay, and let's just do a git push origin feature scale up dev. Okay, it says done. Now it's done, so you go back to your GitHub. Okay, and let's go back over here. You see it says there is a recent push to your branch. So let's compare and create a pull request. Okay, now what is this doing? It is merging your feature branch to the main branch. Okay, and you can just go and do the create pull request. Now because I am also the reviewer, I can just directly merge the pull request, but before that you can just check the commits and file change. So this was the only change that was done. Okay, looks good. So I'm gonna go over here in the conversation and I'll just review it and merge pull request. Okay, confirm merge. Okay, so now it has done, merged and closed. So it should trigger the GitHub Actions pipeline. So let's go to Action tab, and over here, do we see any? So this is 12:25 p.m. Okay, I think it has not triggered yet. Let's verify our GitHub Actions pipeline first. Okay, so let's go inside lessons, and it was day 27. Oh, our GitHub action pipeline code is not here, or what? Okay, over here. So .github/workflows. Okay, and here is the YAML. So what it is saying, this is the name. Okay, on when it will trigger, on push to these branches. So currently we push to the main branch, but we did it via pull request. So pull request also, we have the trigger set based on the pull request on these branches. We are setting some environment variable, which is tf-log is info and AWS secret key ID and secret access key. This is what we have set in the secret variable earlier. We are giving some permissions over here and we are executing this job. Okay, first job is Terraform plan. So it should run on an Ubuntu latest GitHub action runner. Then it will output these variables and then it will run a shell, and these are the steps. First it will do the checkout, then it will set up Terraform, that means Terraform installation. it will set up tf-lint, it will run tf-lint init, then it will run the tf init, then it will run 𝗃𝗏 vulnerability scanning. Okay, then it will run terraform init, terraform format, validate, and again it will set some variables based on the pull request. Okay, so you can go through it. I'm just not gonna bore you with the lot of details. If you are new to GitHub Actions, I will create a dedicated video just for GitHub Actions, because it will be hard if we do everything in one single video. So it is just like any other CI/CD pipeline, a YAML based pipeline. If you have watched my Azure DevOps series, this is similar to that. Okay, so this is just some conditional statements to set some GitHub environment variables and output variables. Then it will also, because we are using Terraform workspaces as well over here, so it will select the workspace and run the plan, update the pull request, and like it does some metadata update. Okay, and then there is the Terraform apply. So it says if the event is push, then again run on Ubuntu latest using this environment. Okay, and again tf init, tf workspaces, tf plan, and finally tf apply using the tf plan that we have generated earlier. Okay, so these sorry. So these are based on the pull request that we have created, and there are different steps for each of the workspaces that we have created. Like if it is if the branch name is main, then workspace name will be prod. If the branch name is test, the workspace name will be test. So based on that, it will execute the further steps based on which branch we have merged the pull request to. Okay, so now what we need to check is if it had created the actions or not. Okay, let's go to, so there are two workflow. One is Terraform drift detection. This is for the 30 days of AWS Terraform. And if we go over here, no, this is not the one, and this is not the one. So we need to create a new workflow. Okay, so yeah, actually we already have the file. So let's see if we need to set up like this, or how do we need to do. Okay, so to workflow, and oh no, it is selecting the GitHub Actions at the root directory, not that repo in which we are creating it, right? So for that, let's see, cancel. Or what we can do is, when we create the new workflow, let's do this. Set up a workflow yourself, and not over here. It should be no, it's not allowing me to use the file inside that. um, mm, 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 mm. So let's go inside our code and lessons, day 27, and inside that code over here, and basically this is the file that we need for the actions, right? So I think I understood the issue, because GitHub Action is not recognizing my workflow inside the subdirectory. So I think I need to move this file to the root of the repository. Okay. Also, I need to add some things over here. Like I need to add the instead of like along with branches, I need to add the path, right? So that it will push only on lessons day 27 code, this folder. Okay, so let me add it over here in the pull request as well. And I think I need to set the working directory as well. Yeah, we need to set the working directory as well. So for that, I'll just copy inside the job, which is over here. Terraform runs on, and along with the runs on, we need default run. Shell is bash, and over here working directory. So this working directory should be the same over here. Where was it? Okay, so it should be this. Lessons at the root repository, and then day 27 code inside the code. Yeah, inside the code directory. Okay, and yeah, I think this should do it. So let me copy this, but let me see if there is any other job over here as well, because we need to set the working directory in all the jobs. I think we only have one job. Let me just do a control F. There is this job. Yeah, there is one job. Or so that's the job Terraform plan. It has these steps, and these are all the steps. Okay, there is Terraform apply. This is also a job, and over here we need to provide the details. So let me get the detail from the job, which is working directory over here, and Terraform apply. So over here we need to add the working directory, and these are all the steps. That's cool. Yeah, that's it. So let me just copy this file and move that to the root directory. Inside this workflows, so over here I'll just add a new file and call it day 27 GitHub provisioning.yml. Okay, paste it over here, and that's it. Let's commit the change. Okay, now if we go to actions, now I see my pipeline over here, Terraform multi-environment CI/CD. There is no run, so let's make a change in that repo. You can do the same thing via GitHub Actions like we did earlier. So yeah, let's do that. Okay, now desired capacity, let's change from 2 to 1. Okay, and let's run the commands, which is git add. Okay, and then we'll do git commit, and let's do a git push. Okay, done. Let's go back. Let's approve the pull request. let's go over here and on which branch, let's go to pull request, new pull request. Okay, and the pull request is feature this to this. Okay, and it says there is one change, like this has been updated to 1. Let's create the pull request, hit create, and now as an approver I have the authority to approve it, so I'm just gonna approve it, confirm merge. Now it should trigger the GitHub action pipeline. So let's go to actions and let's wait. Okay, so over here you see it actually triggered on it. Oh, it actually triggered on commit and on the pull request because we added on the pull request as well. So that's why it triggered for both. So this is the one that we need for now. Okay, and it says Terraform plan is running. What it did till now, it did Terraform init. Okay, Terraform format, Terraform validate. Okay, configuration looks valid. Set some environment variables. It says if the pull request, then set the branch name is this. Okay, and so many other variables it set. It did set the environment variable from the secrets. Then select workspace name. Okay, switch to workspace prod, Terraform plan. Why prod? Because we made the changes to the main branch, that's why. Then there is the Terraform plan. Okay, it has some warning, that's okay. And there is a lot of details, so I'm just gonna go at the very end. So you see there are some changes. Okay, and now it did the post checkout, but did it apply the changes? Let's see over here. It says to perform execs in Terraform apply plan, run this command, update pull request over here, and I think this is the step in which it's applying the changes. So let's go down. Complete job, what does it have? Oh no, that was just that job. Here is the job for Terraform apply. It says skipped. Why did it skip? Maybe Terraform plan is still running. It did completed it. Okay, and no files were found with the provided path tf plan. Maybe because over here Terraform plan, let's go back to the actions again. Okay, so this actually completed, but it did not trigger the apply because it did not find the plan file. Okay, and the job was skipped. So let's go back to actions over here. Okay, and here is our multi-environment CI/CD. No, I just want to review the file. So let's go in the code, GitHub, and workflows over here. Okay, so here it's fine. It was able to do all those things, and then it, let's see where it is generating the Terraform plan file. Okay, init format validate environment variable. Okay, over here. So Terraform plan hyphen var file tf var file output is 𝗃𝗏plan. Okay. And then update pull request, Terraform plan. Okay, so there should be a variable over here which we'll see. It says if Terraform plan status equal to failure, then exit, and then upload Terraform plan to the workspace with 𝗃𝗏plan-workspace name. So it should be 𝗃𝗏plan-prod, path is 𝗃𝗏plan. And over here, when we are doing the apply, we are running this directory, Terraform init, set environment variables. Okay, and then Terraform workspace select, which is prod, download the plan from 𝗃𝗏plan-prod, and then apply. But it did not find it. So let's check it over here, which is settings, actions, general. There is nothing over here. Let's go to secrets and variables for actions. I don't think it will be there because it is just for secrets. What else? Where else we can find it out? Go to actions. And over here, do we have workspaces? No. And this one is also in waiting state. What happened to this? So there is Terraform plan. Okay. And then for apply, it is waiting for the approval because it's prod, right? So for prod, we have the manual approval step. So review pending approval. Okay, let's approve this, approve and deploy. Let's see if this is also failing or not. Run Terraform init, initializing plugin. Okay, branch is main, Terraform workspace name. Okay, switch to prod, download plan. Okay, so it's not able to find the artifacts. So unable to find artifact for plans, TF plan. Okay, let's go back. So let's review the file one more time where we are uploading the TF plan and downloading it. Okay, so here is where we are downloading it. Let's see where we are uploading the file. Okay, so this is Terraform apply. That's okay. Upload Terraform plan. Okay. Oh, so we are uploading it to this directory, but it should be inside that directory, like with code, day 27 and so on, right? So it should be let's edit this. Let's search for upload plan artifact, and yeah, so this path should be lessons and day 27 code TF plan. Okay, and I think the same should be when we are downloading it, which is over here somewhere. Terraform plan download path. I think this one. Terraform plan upload and Terraform plan download day 27 code. Okay, yeah, this should be it. Let's commit the changes. Okay, and let's go to actions. Okay, this is the earlier failure. Now let's trigger it manually because we have already seen the workflow of the pull request. So I'm just gonna trigger this workflow manually. I'm not sure if we can manually trigger it or not, but let's see. Or let me just make the changes directly over there. Okay, side code, and it should be, because it should be triggered based on the merge, based on the check-in as well, the code check-in. I'm gonna go to lessons 27 code and dev.tfrs. Let's make it again to 2. Okay, let's go to actions, and it triggered it. Let's go over here, and basically this is what we are looking for. Okay, so I'm just gonna pause the recording for a couple of minutes while it's doing its work. Okay, plan completed. It's asking me to review the deployment and approve it, so let me do that. Approve and deploy, and let's check it now. Okay, setup, init, environment variables. Okay, download Terraform plan. Now it did. So there is download happen, and Terraform apply is also running now. Okay, it's creating the resources. So I'm just gonna pause while it's doing its work, or is it almost done? Yeah, it's faster than I thought, but I think creation of launch template and all those things, it's gonna take a few minutes. So I'm just gonna pause the recording again. Okay, so for after few minutes, I see the apply has been completed, and it is all green now, and it is showing me some Terraform outputs as well. I can check my load balancer DNS to see if app is healthy or not. So yeah, here it is. It says welcome to infrastructure project. Now we need to check if our changes are applied or not, which is what we did was desired instances equal to 2. So let's go back over here, and let's go to EC2, and there should be 2 instances running, which is, I think, yeah. So there is app instance production, app instance production. 2 instances are running, and they all should be part of the single auto scaling group, which we can check from here. So let's go to the auto scaling group. Desired capacity is 2, which is what we did. And let's check the instances. Instance management, there are 2 instances in service. Both of them are healthy. So this is what we have tested. Now let's do one more. Actually, we'll be doing a few more deployment testing. So let's do one more. And this time we'll be testing the security scanning, if it is working properly with our GitHub Actions pipeline or not. So let's do this thing. Okay, let's check out a new branch, and we're gonna call it git checkout -b security. Okay, and let's make some changes in the security group.tf file over here. Let's, for now, do we have the SSH rule for the app tier? Let's say, okay, so security group SSH, and it is actually opened from anywhere, which is from 0.0, which is restricted, which should be restricted, like it's not a good practice. Okay, and so let's, I think this should have already been captured in our pipeline. So let's go back, and let's go to actions. Okay, and Terraform plan. Let's check ภิvi vulnerability scanning results over here. So we have here it is. This is where it is running it, and then scanning root modules, blah blah blah. Okay, let's go back. It has actually scanned all the files in all the folders. Okay, now here is there are some critical vulnerabilities. It says application load balancer is not set to drop invalid headers. Okay, that's one. Then we have like it is providing the line details as well where you can fix it. Then load balancer is exposed publicly. So because we are using an external load balancer, it was supposed to be exposed publicly, but it says there is a check. uh, it just it just asking us it is really a valid thing to do for this particular use case. I mean, it was really necessary, right? Then we don't have the HTTPS. We were only using HTTP traffic over port 80, which is also not secure. So it is providing all the vulnerability details, and the here's the code snippet as well. Then now these are the details from other files, which let's not worry for now. But you see all the vulnerabilities it has already presented to us, and it's highly detailed. There are a lot. You can keep going on and on, and it has checked all the vulnerabilities that we wanted to see. Now let's check the vulnerabilities for day 27. Okay, so this is for day 27. It says you should limit the provisioning of public IP for resources. Resource should not be exposed on public internet. Maybe there is some over here. You see public map public IP on launch equal to true for AWS subnet. I mean, this was public subnet, but still it is throwing the error for us. The same way it is doing for other one as well. And here is the security group setting, because we have opened it for the world. So now it is also saying that it is not recommended, right? You should allow only to your IP or your CIDR, and it should not be allowed unrestricted ingress from any IP address. So these are all the vulnerability scannings that it did. Okay, now let's go and test our second workflow, which is for Terraform destruction. Okay, so let's go over here to, actually we have to do the same thing. For that we have to move the file from the subdirectory to the root directory. Okay, so let's go inside lessons, day 27, and then code, GitHub workflows, Terraform destroy, this one. Okay, so let me copy this file content and let's go to the root directory inside .github workflows. Over here, let's call it destroy day 27.yaml. Doesn't matter what file name we'll give, because it will take the file name that is there over here, right? Name. Okay, so let's verify this once. On workflow dispatch, input environment to destroy required equal to true, default is dev, choices are this. It will ask your choices. It's not on pull request or not on merge. It's basically asking the user input which environment to destroy. Okay, and that's good. Then Terraform destroy, I think we need to run it on the same folder, right? So let me copy that from the other tab. So let's go to actions. Okay, and Okay, my mind has stopped working now. I'm not sure what I'm doing. So let's go over here to this file, workflows, provisioning. Okay. So what we need is path, which is from here, working directory. So let's copy from here. Okay. And this is for Terraform destroy. There is one job. That's cool. And yeah, I think that should do it. Okay, let's commit the changes. And once you commit the changes, now if you go to actions, you should see another workflow over here, which is for Terraform destroy. Click on that, run workflow, select the branch, select the environment. I think we have prod environment, type destroy to confirm, and hit run workflow. Okay, still not triggered yet, so let's wait. Okay, it has been triggered. Click on that. Now it is waiting for my review because again it's a prod environment. So let's approve and deploy. Now let's check this in real time. It's verifying the confirmation. Yes, I did verified it with the destroy keyword over there. And then it is doing its work. It is running the Terraform destroy, destruction complete for route table. Yeah, so it is doing its destruction. So let me just pause the recording while it's fully destroy the infra. Okay, after few minutes, it shows that it has completely destroyed 33 resources. Let's go and check out over here as well in auto scaling group. I don't see anything. Let's check in EC2. Oh, I still see, no, it's gone. It was from the, like it was not refreshed properly, right? And we can check the load balancer as well, just to make sure there are no load balancer as well. So all the resources have been destroyed successfully. We have tested both the pipelines. We have tested the infra provisioning, destruction, and changes, including the security scanning with 𝗔𝗲𝗃. And there were some TF-lint result as well. So you can check those as well. I hope you found this project helpful and valuable. This is a real-time use case again, because when you work in an organization, you won't be running Terraform commands manually. You most probably be using any such CI/CD pipeline along with Terraform. And we had one more step missing in this, which was drift detection. And this is again a crucial one, so which I have covered in one of the later videos. So keep following, keep watching, and keep supporting the channel. Keep sharing it with your friends, colleagues, family, whoever is trying to upskill into DevOps, Terraform, etc. And thank you for your support. Thank you for everything so far. And yeah, that's it. Thank you. And I hope you found it helpful and valuable. I will see you tomorrow with the next video. Thank you so much. Happy learning.